Good day to everyone. I am here to discuss about Lab 4 examining plugs. Our activity 1 is to write and assemble a program to add the following data, then use the simulator to examine the C, H, Z plugs after the execution of each addition. As you can see here, I initiated the value of R16 as 92, R17 as 23, R18 as 66, R19 as 87, R20 as F5. That is the given value to us. Then we're going to add those. So adding R17 and R16 will give us 181 in decimal. In hexadecimal, that is B5. So the plugs are on is R, S, and N because the result is negative. So the N plug or the negative plug is on. So does the S plug because it is a sign bit plug that is on whenever the result is a negative. We're going to add next is R17 and R18. We will get the result as 27 on R18. And as you can see, C plug is on, and because C plug is a overflow, or the value of that register is greater than the 8-bit register can hold. Next, we're going to add R19 and R18. As you can see, the H plug, S and N plug are on because H plug is a overflow between the upper and the lower 4-bit values or a nimble, and S plug and N plug are on because, as I said earlier, that the result is negative. So last one, the value of R19 is A2 and decimal, that is 162. So last one is R20 and R19. And you can see that C plug, N plug, and S plug are on because the result is negative. Also, that it is a carry because the value is 151 and it is an overflow in hexadecimal, that is 0x97. Activity 2. Write and assemble the following program. Use the simulator to single step and examine the plugs and register content after the execution of each instruction. So here is the program, and we are going to execute it in ABR. So we are going to build and run. First, we see that the value of R20 is 27, R21 is 15. When you subtract it, there is no plugs yet. And let's move on to R20. R20 has the value of 20, R21 has the value of 15, and as you can see that the H plug is on because H plug only turns on when there is an overflow between the upper and the lower 4 bits of a register, or it is a nimble. Next is R24 has the value of 95, R25 has the value of 95, and if we subtract those two, we will get a Z plug or 0 plug, meaning that the result is equal to 0. Next is LDIR22, which has the value of 50, LDIR23 has the value of 70, and if we subtract those two, we will get an HSC and N plug because the result is a negative, because if you subtract 50 from 70, you will get negative 20, and it is a overflow between the upper and lower 4 bits of the register. Also, it is a carry because it is greater than the 8-bit register can hold. Next is activity 3. Write and assemble a program to load the value into each location R20 to R23. Use the COM instruction to complement the value of each register. Use the simulator to single step and examine the plugs and register contents after the execution of its instruction. So here is the program, and we are going to execute it in the ABR. We're going to set that as binary, so we can see that it complements correctly. Let me adjust it. There we go. And we're going to build and run. As you can see that the value of R20 right here is 0. R21 is F. R22 has the value of 11. And R23 has the value of 22. So, first we are going to complement the R23 here. You can see that it is complemented, and it has a C, N, and S plug because it complements itself. When you complement itself, it's either you get the positive value or a negative value. So here we can see that S and N plug has a is on because the result or the value in R20 is negative. Thus it also has a C plug because it overflows the value or it exceeds the value of the 8-bit register. Next is the R21. In R21, we can see that it is all 1. If we complement it, we will get a Z and a C plug because, as I said earlier, C plug is a overflow and Z plug is when the result is 0. So next one is R22. R22 has a value of 11, and if we complement it, we will get this, and the plugs are S, N, and C, which means that the result is negative, thus it overflows with the 8-bit registers. Last one is the R23 with the value of 22. If we complement that, same as the R22, it results in S as S, N, and C because the result is negative, thus it overflows with the 8-bit register. Last one is activity 4, in which we are tasked to find the value of C plug after execution of the following codes. Here is the code, and we are going to execute here in the ABR. We can see that R20 is loaded the value 85, R21 is loaded with the value of 92, and when you add those two, we will get the value of 0x17, and the C plug is on because it overflows, or it has the value greater than the 8-bit can hold. Next is R16 with the value of 15, R17 with the value of 72. If we add those two, we will get 0x87, which is equivalent to 135 in decimal, and also it turns on the C plug because of its it didn't turn on the C plug because that value is, or it can hold that value on the 8-bit register. Next is the LDI R25 with the value of F5, LDI R26 with the value of 52. If we add those two, we will get a C plug, and we will get the value of the new value of R25 as 0x47 or 71 in decimal, and it is a C plug because it overflows, or it has the value greater than the 8-bit can hold. Last one is R25 with the value of 0xFE. Then we are going to increment it. Then 0xFF, that is 255 on decimal. And if we increment it one more time, we will get the value of 0. And as you can see, the Z plug is on because the result is 0. And the carry plug is on because the 8-bit register has already been overflowed, or the 8-bit register has already been full, so that it will carry on to the next register, or it will have the value of 0.